And in this section, we're going to talk about parallelograms. So we started talking about quadrilaterals. Quadrilaterals are a huge category, and you can break them down into special quadrilaterals. The first one of those is a parallelogram, and you'll see that parallelograms are really something special, okay? They really are. You might even, I don't know what your favorite shape is, but you know what? Parallelograms might just take over after this lesson. All right. So first of all, let's talk about what a quadrilateral is. Let's not forget the fact that it's just a four-sided polygon, okay? And we're going to talk about parallelograms. That's one type of quadrilateral. There are also rectangles, rhombi, that's the plural of rhombus, squares, and trapezoids. All right? Actually, we're also going to talk about kites. Okay. If I say the word parallelogram, okay, what's it made of? The word parallel. That is the definition of a parallelogram. There was a proof on the final on parallelograms, remember? Yeah. I remember. All right, so a parallelogram is a quadrilateral with both pairs of opposite sides parallel. This is the definition of a parallelogram. A parallelogram also has several other properties. Please don't confuse them with the definition. The definition comes from the word from which it's made. It's a quadrilateral with both pairs of opposite sides parallel. So if on the test I ask you, what is a parallelogram? And you say, a quadrilateral with parallel sides, not the complete answer. A quadrilateral with two parallel sides, not the complete answer. With both pairs of opposite sides parallel. Please, please, please remember that. Okay. In a proof, if you want to use this fact, it's definition of a parallelogram. Okay? All right. Now, we have several theorems that involve parallelograms. Let's talk about the first one. Theorem 6.3 says, if you have a parallelogram, or a parallelogram implies a parallelogram implies opposite sides are congruent. So if you have a parallelogram, then the opposite sides are congruent. Are these, the markings are, yeah, so I have to be smart and do it above so it shifts. No, it's not calibration. This is what happens when you ink in a table. Anyways, so the first theorem is when you have a parallelogram, the opposite sides are congruent to each other. What was the definition? The definition said that if you have a parallelogram, then opposite sides are parallel. The next theorem is if you have a parallelogram, the opposite angles are congruent. Okay? You get the idea. All right, the next one is, if you have a parallelogram, consecutive angles are supplementary. Consecutive angles, right? And we already know this. Yes? Because if I have two parallel lines and a transversal, then same side interior are supplementary, right? Well, what are consecutive angles? This one and the one right over. They're supplementary. Okay, so if this angle is 130, or if this angle is 50, okay, how big is the angle right next to it? 130. Now, if this is 50, it has another consecutive angle. This one, how big is that? 130. Okay? Huh? And they all have to equal 360. Awesome. Okay? Somebody was listening last time. Good. All right? So consecutive angles, no matter which way you look at them, are supplementary in a parallelogram. And look, when you do it that way, automatically the opposite angles end up being congruent. That's so cool. It really is. Okay. So, what does this imply? Okay. If one of these angles happened to be a 90-degree angle, all right, then what would that say about all the rest? They're all 90-degree angles. Huh? Why not? There can be. You could have any angle. All right? It's a rectangle or a square. All right, another one. In a parallelogram, diagonals bisect each other. Now this is going to be tricky. Let's see. Ooh, almost. Yeah. Not too shabby. That's perfect, huh? I'm getting good at this. So the diagonals bisect each other, meaning this first diagonal cuts the first one into two congruent parts, and it cuts this one into two congruent parts. Okay? So each one of the diagonals bisects the other one. The next theorem is a diagonal separates the parallelogram into two congruent triangles. So, here, that fell through, that's all right. So, A, B, C, D, triangle ABC is congruent to triangle CDA. Okay? So that's all the stuff about parallelograms. Do you have to know these by heart? Yeah, you do. Okay? So say them every night, like 10 times before you go to bed, and it should do it. All right? So here it says to prove theorem 6.3 and 6.4, which say that in a quadrilateral, opposite sides are congruent and opposite angles are congruent. And we can prove both in one proof. Okay? So you're going to prove that AB and CD are congruent, AD and BC are congruent, angle A is congruent to angle C, angle B is congruent to angle D. Actually, not this one. And you'll see why in a minute. Okay, so what you're given is parallelogram ABCD. Make it look like a parallelogram. Okay? Now, if you're just given a parallelogram, what's the only thing that you know? Right, the definition. So number 2 is AB is parallel to CD and AD is parallel to BC. That's the definition of a parallelogram. Okay? Now, I want to prove that these two angles are congruent to each other. And I want to prove that AB and CD are congruent, AD and BC are congruent. The only way for me to do that, or the best way for me to do that, is by triangles. So what I want to do is I want to split this up into two triangles. Now, if I prove that the two triangles are congruent, then I can prove everything else is congruent by CP/CTC. Okay? What I said so far is that these two sides are parallel and these two sides are parallel. To prove triangle congruence, I now have to say BD is congruent to BD, reflexive. Okay? Now, I have two parallel lines here and a transversal. That means that this angle is congruent to that angle because of alternate interior angles. So I say angle ABD is congruent to angle BDC, and this angle and this angle are congruent. So angle ADB and angle CBD, not the same ones. Oh no, it's the same, yes, same step. This is because when you have parallel lines, they imply alternate interior angles are congruent. So what I have now is, here I have a side that's congruent, I have an angle, and I have an angle. So is it AAS, ASA, what is it? It's ASA. Angle, side, angle. All right? So I say triangle ADB is congruent to triangle CBD because of ASA. And now, whatever you want can be congruent, right? So AB is congruent to CD, AD to BC, angle A to angle C, all because of CP/CTC. Okay? Yeah. Well, no, because that's how we split up the triangle, you know what I mean? But angle B is the whole thing. That takes a whole other proof. Because you have to add angles, angle addition postulate, and so on. Here we're going to prove theorem 6.7. Okay? So we're going to draw another diagonal. And we're given, in this case, parallelogram ABCD. And that's the given. We have to prove that, you should write that too. We have to prove that AE is congruent to EC and BE to ED. Okay, so if we know that we have a parallelogram, then we know that these opposite sides are parallel. So AB is parallel to DC and AD to BC. Definition of a parallelogram. Okay? Next, here I have vertical angles, right? So I say angle AED is congruent to angle BEC. Vertical angles are congruent. Next, yeah, this angle now is congruent to this angle, right? Because of alternating interior angles. Right, either or. So this one, it's going to be angle ADE, congruent to angle EBC. Parallel lines means alternate interior angles are congruent. Okay. Number 5. Now, we can also prove that these are congruent, right? The opposite sides are congruent. So AD, congruent to BC. Parallelogram implies opposite sides congruent. Now we're ready to show that these two triangles are congruent, right? So triangle ADE, the one on the left and right, is congruent to triangle CBE. Because of AAS. Okay? Now, if the triangles are congruent, what does that mean? That means that this and this are congruent to each other because of CPCTC, and it means that this, and this are congruent to each other because of CPCTC. So AE is congruent to EC, DE to EB, or BE to ED, CPCTC. Are we done? Why? What's the next one? There you go. We want them to be equal, not congruent. So the next step is AE is equal to EC, BE is equal to ED. Definition of congruent segments. Such an awesome proof. Yeah. We're given parallelogram XYRZ, and it's hidden in that triangle over there. We're also given that WZ, this entire line, is congruent to WS. So this is congruent to that. All right? Yeah.
How do we show that it's congruent?
It's given.
No, like if we're drawing that, how do we make congruent signs?
You can either highlight and say that it's congruent, or sometimes you can say this is congruent to that, like this. You know? Yeah. So let's write down our given. We have a parallelogram and two congruent lines. What do we want to do here? We want to prove that angle XYR is congruent to angle S. Oh boy. Okay. All right. What do we know about? Oh my God, this is such an awesome proof. I just love it. What do we know about a parallelogram? We're talking about angles now. We're talking about angles now. See, we want angles to be congruent. Wait. We're talking about angles, okay? What do we know about the angles of a parallelogram? Opposite angles are congruent. So I know that this is congruent to that. Now, focus on the big triangle. What kind of triangle is it? It's an isosceles triangle, meaning the base angles are congruent. So all three of those angles are congruent. Lovely. Let's start. Okay. So one more time, slower. Okay. Now. Okay, hang on. Okay. 1, 2, 3. 1, 2, 3. Okay. Now, angle Z is congruent to angle XYR because a parallelogram means opposite angles are congruent. Number 3. This big yellow triangle is an isosceles triangle, which means that this and this are congruent. Angle Z is congruent to angle S, isosceles triangle theorem. Now, XYR is congruent to angle Z. S is congruent to angle Z. That means angle XYR is congruent to angle S, transitive. In this one, SV is congruent to VQ, or QV if you want to be symmetric, because in a parallelogram implies that the diagonals bisect each other. Angle SRQ is this one. It's congruent to the opposite angle, STQ, because a parallelogram implies opposite angles are congruent. QT is congruent to the opposite side RS because, right, angle VRS, triangle VRS is congruent to triangle VTQ, right? So triangle VRS, this one, VTQ, because this angle goes with this angle. Right, it's SAS. Yes. So what happened? There is no such thing. So this angle here is congruent. Vertical angle is congruent, okay? So vertical angles, the fact that the diagonals are bisected, and SAS. Next one, angle TSR is supplementary to angle what? Or SRQ or STQ, right? Because in a parallelogram, consecutive angles are supplementary. Yes. If it says, name an angle, then no. But if it says something like this, then you should. Yes. In this one, we have to, again, use the properties. So we know that Opposite sides are congruent to each other, meaning 3a equals 21, a is equal to 7. So here a is equal to 7. Here these two opposite sides are congruent, so 2b plus 3 equals 45. So b equals 21. Now, measure of angle MJK is this one. It's congruent to the opposite angle, which is 100. Okay. Measure of angle JML. JML is this one. So if this is 100, then this is 80 because of consecutive angles. Measure of angle JKL, this one, is 80 because it's congruent to JML. Now we're left with measure of angle JKL, this one here. Okay? If this triangle is congruent to the one on top, then if this is 30, this is 30. So this is 30. Okay? Last but not least, we're given parallelogram VZRQ, this long one, and WQST. So you have a horizontal and a vertical inserted into each other. You want to prove that angle Z and angle T are congruent to each other. Okay? So, look at this one. Very, very quick. We're given parallelogram VZRQ and parallelogram WQST. So what do we know about the first, the vertical one? We know that this and this are congruent, right? Because opposite sides are congruent. And we know that these two are congruent. Okay? What do we know about the horizontal one? I know that Q is congruent to T. Well, look, I want Z congruent to T. I already proved it. Okay? So I say angle Z is congruent to angle Q, and angle Q is congruent to angle T. In a parallelogram, opposite angles are congruent. And the third one is that angle Z is congruent to angle T, transitive. All right? So this homework is due next time. All right?